Good morning, students. How are you all? So, in last class, we have seen about the problems up to Ohm's law, and in that, we have seen V equal to IR is the formula. So, after that, we will come across the combination of resistors, so that resistors can be connected in series and parallel. There are the two types of combinations of resistors. So, resistors in series and resistors in parallel. These are the two types of the combination of resistors. Okay, we'll see first resistors in series. So, how will be the diagram? See, let us connect an ammeter here. So, this is my plus minus, which should be connected to the positive of the battery. They should be connected like this. Okay, this is my positive of the battery, negative of the battery. Positive of the battery should connect to the positive of the ammeter, negative of the battery should connect to the negative of the ammeter. So if I make here, this is my R1, this is my R2, this is my R3. So these are the three resistors which should be connected here with the switch. Okay. And we have to take voltmeter in parallel with resistors. Okay, this is my voltmeter. This side is plus and this side is minus. I hope this much is clear. No doubts in this resistors in series circuit. So this is the circuit. And when there is a battery, there must be a flow of current. We have to always show the direction of flow of current. Remember, in any diagram, the compulsory things are battery or cell, resistor, and flow of current. This is the minimum things we require in a circuit diagram. And after that, then you can go for ammeter, voltmeter, and resistance or loads must be there. These are the battery, resistor, and flow of current. These are the important things you must denote in a circuit diagram. And if you take a little bit along the circuit diagram, so we can take key there which is closed ammeter and voltmeter also with flow of current, battery and resistors. So this is resistors in series diagram. Here you can see three resistors are connected in series. What is series connection? When resistors are connected end to end, then we call it as series connection. I will show you for example. See, these are the let me tell you. So when these are two resistors, if you take these chalk are two resistors, these should be connected like this. When these should be connected end to end, means end of the first should connect to the start of the second resistor. Then we can say that these resistors are connected in series. If I take continuously to the third one, so these three are said to be end to end resistor. They are connected in series. Series means what? All the three resistors are connected end to end. So, end to end resistors means they are the series resistors. When the resistors are in said to be series, when the resistors are connected end to end, then the resistors are said to be in series. I hope you all are getting my point. When resistors can be bulbs, okay, those which are opposing the flow of current, those are resistance, and there is some resistance in bulbs. So in place of resistors, sometimes we can take bulbs, okay. So the resistors which are connected end to end, they are called resistors in series. I hope you got this point. This is the circuit diagram. Please draw this diagram. Please draw this diagram. Okay. Pause the video and draw the diagram. So whenever you listen to the science class, always keep a note with yourself and always note down whatever written on the board. Okay. So note down this diagram. So we'll go to the formula in this diagram. Okay. Let us apply Ohm's law to this circuit. See here, If you see this, you can know that the current is flowing same through the all resistors. Through the all resistors, same current is flowing. I is the same current that is flowing through R1, that is flowing through R2, that is flowing through R3. It is not changing. Current is not changing. But we can say that there is a change in voltage. So this is the voltage, we can say. This is V. So this V will split here. If I take this point to this point, it will be my V1. So if I take from this point to this point, this will be my V2. If I take this point to this point, it will be my V3. So V1 is along R1, V2 is along R2 and V3 is along R3. That means V1 potential difference 1, voltage 1 is across R1, V2 is across R2, V3 is across R3. Including all these three, my V is there. That means V is equal to V1 plus V2 plus V3. Remember this concept, in series current is same but voltage is not same. In series resistor current through the all resistors is same but potential difference across all the resistors are different. So we have to go through that one. So consider, you have to always consider a series combination of resistors. Consider series combinations of resistors as shown in the circuit diagram. Resistors as shown in circuit diagram. Okay. Let us apply Ohm's law here. Okay. Applying, so here after this, and applying Ohm's law to the circuit. And we know that, rather than that, we know that same current I flows through all resistors. Flows through all. Please note down this. This is the derivation. Flows through all resistors. Same current I flows through all resistors, but potential difference in resistors is different. Potential difference across each resistor is different. Each resistor is different. Okay, please note down this. Note down these points. Potential difference across each resistor is different. Now, okay, I am going to solve you proper. Now we know that. What we know? Here V is equal to V1 plus V2 plus V3. Do you agree? Yes. Why? Because the voltage or the potential difference that is given by the battery, that is given by the supply, that will be divided into V1, V2, V3. That will be split into V1, V2, V3. And the resistors are in series. See, the ends are changing here. For potential difference, both the ends should be same. When both the ends are same, then we can say that the potential difference is same. But here in this case, for R1 these two are end, for R2 these two are ends, for R3 these two are ends. Means the ends are changing. When the ends are changing, potential difference will be different across the resistors. So what is my potential difference? Potential difference, the total potential difference is equal to the sum of my potential differences of individual resistance. So that we can say that V is equal to V1 plus V2 plus V3. V is equal to the total V, or this V is equal to V1 plus V2 plus V3. You don't draw this diagram V1, V2, V3, just for understanding I have drawn those. Okay, now my V is equal to V1 plus V2 plus V3. I hope you all know what is V according to Ohm's law. V is equal to what? IR. So V1 is IR1. See, V is equal to IR. So this is the series combination. So I will write it as IRS. Total resistance. If I remove all the three resistance and replace by one resistance, that will be my RS. Effective resistance of all the three resistors. For example, if three students of 5th class are doing some work, instead of all the three students, I remove all the three students and I will put some 10th class student who will do the same work. That is addition of all those three works, and he will be the effective person of those three persons. Okay, that means one resistor, that is RS, is doing all the work that has done by R1, R2 and R3. So that is resistance in series, IRS. Here V1 what we are getting, this is R1 and current is I. The same current I is flowing through there. No need to write I1 R1. I1 is I here, I2 is also I3 is also I. That means IR1 plus IR2 plus IR3. IRS is equal to IR1 plus IR2 plus IR3. So what happens next? So IRS is equal to, okay, IRS is equal to, in this case what is common? I is common. So I will take I outside, R1 plus R2 plus R3. IRS is equal to I into R1 plus R2 plus R3. So my I gets cancelled here, right? I can cancel my I here. So we can take I this side, I cancels. So RS is equal to R1 plus R2 plus R3. This is the required formula. RS is equal to, remember this formula, this is very much important. So this is RS is equal to R1 plus R2 plus R3. If there are three resistors, if there are two resistors, RS is equal to R1 plus R2. If there are four resistors, RS is equal to R1 plus R2 plus R3 plus R4. That means how many resistors may connected in series? For the effective resistance, you have to add all the resistors. This is the basic concept. So what you have to do, if the resistors are connected in series, the effective resistance is addition of all the individual resistance RS, that is equal to R1 plus R2 plus R3, right? RS is equal to R1 plus R2 plus R3. So this is the important thing. You have to remember all these things. Very easy one. If you have to remember this series combination diagram, draw the diagram in the note. Okay. So series combination diagram, what is important in series combination? The current is same. R1, R2, R3 all have the same current, that is I. But the ends are changing here. They are connected end to end, not to the same end. Okay, when they are connected end to end, we call them as series combination. They are connected in series. That means current is same, but the potential difference across each resistor is different. We have to take that, okay, and we have to write it as, in derivation, consider a series combination of resistors as shown in circuit diagram. We know same current, we know that same current I flows through all resistors, but potential difference across each resistor is different. Okay, so what we know now, V is equal to V1 plus V2 plus V3. In parallel, in series combination, the potential difference splits with each resistor because the ends are changing. For the potential difference to be same, the ends should be maintained same. But here the ends are not same. That means the potential difference splits. So V is equal to V1 plus V2 plus V3. Current is same. The same current flows through R1, R2 and R3. Remember, in series circuit, the current will not change. This question can be asked in multiple choice question. What is the thing that will not change in series circuit? Voltage, resistance, current and electrical energy. There might be option, you have to choose current. Current will not change, or another way they can ask, what is the physical quantity that remains constant in series circuit of resistors. Okay, that also you have to say, there also you have to remember it is correct. Okay, so V is equal to V1 plus V2 plus V3 here. So we know that according to Ohm's law, V equal to IR. So here that is the effective resistance we are taking means V I is there and in place of R we have to take RS series resistance. V1 is IR1, V2 IR2, V3 IR3. So why? Because V1 is equal to IR1 because the same current I flows through R1, same current I flows through R2, same current I flows through R3. So IR1 plus IR2 plus IR3. So then we have to take I common in this. I have taken common. So IR is equal to I bracket R1 plus R2 plus R3. I gets cancelled here. RS is equal to R1 plus R2 plus R3. So this is the formula I needed. So this is regarding resistance in series. I hope you all are clear with this point. Please note down this. Okay, and we'll move to the next. So these will come in your exam definitely. So note down this and we'll move to the next. By pausing, you can note down. Okay. So we'll move to the next concept, that is resistors in parallel. Series we have seen, just we have to see resistors in parallel. Parallel combination of resistors. Series combinations of resistor or parallel combinations of resistors. Okay. So parallel combination of resistor, we can say parallel combination of resistors. Resistance or resistor, both are same. Parallel combination of resistors or resistances. Okay. So now I will draw the diagram. Same diagram will be there. Let me take a meter here. Plus, minus. Okay. Battery. My plus here, minus here. Either closed by key. Okay. Here if you look, see here. This is my point. This is my first resistance. So these are the three resistors which are connected in parallel. R1, R2, R3. So this is my V. The same will come here. So I can connect a parallel voltmeter across the resistors. So of course voltage is there means there is flow of current. So this is series combination of resistors. Sorry, this is parallel combination of resistors. Okay. So parallel combination of resistors means what? What we have seen in series combination, the resistors are connected end to end. See, resistances and resistors, there is no difference. Okay. Those who are having resistances, these are called as resistors. Okay. So parallel combination of resistances or resistors, both are same. So here three resistors are there means they are connected in parallel. Parallel means you can see there in mathematics you come across parallel word. So they are all in parallel. You can see R1, R2 and R3 are in parallel. In another way we can how we can say that they are in parallel means their end is same. See, the end of this R1 is this. Okay, this is my end of R1, whereas this is my end of other end of R1. Similarly, this is the one end of R2, this is other end of R2. R3 also, this is the one end, this is the other end. So if the ends of resistor, all the ends of resistors are same, we call it as parallel combination. When we call it as a parallel combination, all the ends of resistances are same. When resistors are connected to the same ends, we can call them as parallel combination. What is series combination? They are connected end to end. In series they are connected end to end, but in parallel they are connected to the same end. Okay? When they are having the same ends, these two are the same ends for all the three resistors. Then we have to say that they are in parallel combination. Okay. So here, very easily you can see here, what will be, if the ends are same, potential difference will be same. Here current will not be same. I will show you. The current will come here, but there will be three ways or paths for current. Suppose if the water is flowing here, and if it has three paths for flowing, will it flow in the same flood? No, it gets splits in different paths. Okay, the current will split to I1, I2 and I3 here. So it will become I1 here, it will become I2 here, it will become I3 here. Through the resistor R1, current is I1. Through the resistor R2, my current is I2. Through the resistor R3, the current is I3. But here voltage is same. The same voltage is here, also same voltage is here. The voltage, effective voltage will be same here. Because the ends are same. The voltage across R1 is also same. The voltage across R2 is also same. The voltage across R3 is also same. Because the ends of the all resistors are same. Potential difference is measured across ends. So it is measured across the ends. So the potential difference across each resistor will be same. Remember this thing. The potential difference across each resistor same when the resistors are in parallel. When the resistors are in series, current is same. Okay. Now current splits here. Same thing we have to say again. We have to write. Let us consider what we have to consider, parallel combination of, write down this in notes. Okay, this is again derivation. Let us consider parallel combination of resistors as shown in circuit diagram. We have to draw the diagram as shown in circuit diagram. Here potential difference across each resistor is same. Potential difference across means parallel. Each resistor is same. Each resistor is same, but current through each resistor is different. Current through each resistor is different. Each resistor is different. Okay, you have tried this, and now we'll go for the derivation. So, what it will become? So, what it will become? I is splitting into I1 plus I2 plus I3. So, I is equal to, there B is equal to V1 plus V2 plus V3. Here I is equal to I1 plus I2 plus I3. That means, again apply Ohm's law. What is my I? B is equal to IR according to Ohm's law. So, what is my I? V by R. I is equal to V by R. So, V by R means here what? RP. RP is effective resistance in parallel. So I1 is, what is my I1 here? Okay, the same V is there, V is same all across all the three resistors. What is my I1? V by R1. So what is my I2? V by R2. What is my I3? V by R3. What I can take common here? Here I can take V as common. So I will write here V into bracket 1 by RP is equal to V into bracket 1 by R1 plus 1 by R2 plus 1 by R3. So my both V get cancels. What is remaining? 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the required formula. 1 by R1 plus 1 by R2 plus 1 by R3. 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the parallel combination of resistance. What is important in this concept? Voltage is same across all the three resistors. How we can say it is a parallel combination? Because all the resistors are connected to the same end. Okay? In series combination, resistances are connected end to end. And in this parallel combination, the current will split here. But the voltage across each resistor is same. So remember one thing, in series current same, in parallel voltage or potential difference is same. So let us apply the Ohm's law for this. You have to write this. Let us consider parallel combination of resistors as shown in circuit diagram. Here potential difference across each resistor is same, but current through each resistor is different. Okay. So now I is equal to, so what we know from the diagram? So I is equal to I1 plus I2 plus I3. So we know that I is equal to I1 plus I2 plus I3. What is my I according to Ohm's law? V by R. So here it is parallel combination means V by Rp. I1 is V by R1, I2 is V by R2, I3 is V by R3. V is same. So V by Rp. So I can write it as V into 1 by Rp. So here if I take V as common, remaining inside 1 by R1 plus 1 by R2 plus 1 by R3. So then 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula required. So Rs is equal to R1 plus R2 plus R3. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. For parallel combination, this is the formula. If there are only two resistors, 1 by Rp equal to 1 by R1 plus 1 by R2. Enough. If there are four resistors, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Okay. So in series also same. Rs is equal to R1 plus R2 if there are two resistors. Rs is equal to R1 plus R2 plus R3 plus R4 if there are four resistors. So you have to remember these two formulas. Series resistors, series combination of resistors and parallel combination of resistors. So please take care of these formulas. So we will see about the remaining things in the next class.